What's up guys, this is Demkeys and today I'm going to teach you how to use the FixedJoint2D component. This joint aims to maintain a relative linear and angular offset between 2 points. Those 2 points can be two rigid body 2D components or a rigid body 2D component and a position in world space. One of the major differences between a fixed joint 2D and a relative joint 2D is that a fixed joint 2D is a spring type joint, whereas a relative joint 2D is a motor type joint with maximum force and torque. So let's begin. Now first of all, I want you to drag the game view down here so that our scene view doesn't get hidden each time we play the game. Next, right click in the project panel, click create sprites square. Name it whatever you want. Basically we are trying to create a blank sprite. Drag and drop this into the scene and add a box collider 2D component to it. Make a duplicate of this game object and bring it down here. This is going to be our ground, so resize it to make it look like ground and rename it to ground. Make another duplicate, bring it over here, resize it, and you can rename this object to block. Make another duplicate, bring it over here and resize it and name this object joint part 01. Add a rigid body 2D component to it and make a duplicate of this game object and bring the duplicate beside the original and rename the duplicate to joint part 02. Now select joint part 01 and I'm just gonna move this block a little bit to the side. Now both these game objects are not connected together. Each of them has a rigid body 2D component and a box collider 2D component attached to it. So when we play the game, then this is the behavior that we get. Now select joint part 01 and add a fixed joint 2D component to it. The fixed joint 2D component is added down here. Now just so we don't end up having to scroll down each time we want to take a look at this component, right click on fixed joint 2D and click move up and repeat this step a couple of times until the fixed joint 2D component is up here and you don't have to scroll down to look at it. Next, with joint part 01 selected, drag and drop joint part 02 into the connected rigid body field. And now let's play the game and see the behavior. As you can see, both of these game objects are behaving as if they are joined together. This is because of the fixed joint 2D component. So let's take a look at some of the properties of the fixed joint 2D component. We're going to start with connected rigid body. This lets you specify the other game object that this fixed joint 2D connects to. If you leave this to none, then the other end of this fixed joint 2D is going to be connected to some point in world space. But if you do actually specify a connected rigid body, as we have done over here, then the other end of this fixed joint 2D will be connected to that rigid body. I'm saying other end over here because one end of the fixed joint 2D is connected to this game object being joint part 01. So that's connected rigid body. Next we're going to take a look at anchor and connected anchor. Anchor is the place where the end point of the joint connects to this game object being joint part 01. Connected anchor is the place where the other end of this fixed joint 2D connects to the other game object being joint part 02. The anchor position is always going to be in the local space of this game object, the game object that the fixed joint 2D is attached to. And the connected anchor position is always going to be in the local space of the other game object, the connected game object. And if you don't specify a connected rigid body, then the connected anchor position is going to be in world space. Alright, now you cannot see the anchor or the connected anchor right now. And that's because our transform gizmo here is obstructing our view. So first of all, I'm going to move joint part 01 such that there's a little bit of space in between joint part 01 and joint part 02. And next I'm going to change from the translate tool to the rect tool. So now the gizmo is not obstructing our view and this right here is our anchor. It's actually the anchor and the connected anchor. Both are in the same position. We are going to change both their positions now. Alright, so for now I want you to uncheck auto configure connected anchor. We'll go into this a little bit later, but for now just uncheck it and now you can change the anchor position and the connected anchor position. Before you change it, I want you to notice that the anchor position on X and Y is 0 and the anchor, as you can see over here, is in the center of joint part 01. This tells you that this anchor is in the local space of this game object. So now when I change the value on the X axis, you'll see the anchor point moving. And just to show you that the anchor point can actually be placed outside the game object, I'm going to bring it outside here. Next, change the connected anchor position. This this is the connected anchor. And again, to show you that the connected anchor position is in the local space of the connected game object, I'm going to set both the x and y. Well, y is already 0. I'm going to set the position on the x-axis to 0. As you can see, the connected anchor comes in the center of the connected game object. This is how you know that the connected anchor position is in the local space of the connected game object. So I'm going to change this position and bring this anchor a little bit over here. Now, what's going to happen when you play the game is that the connected anchor and the anchor are going to come together. Let's see if that happens. Right now, as you can see, they're both separated from each other, but when I play the game, they come together. Now, given the fact that the anchor position is in the local space of joint part O1 and connected anchor position is in the local space of joint part O2, if you want to set the connected anchor position to be the same as the anchor position, you're going to have to perform certain calculations. If you check auto configure connected anchor, the FixedJoint2D component does the calculation for you. So now the connected anchor position is always going to be the same as the anchor position, which is why when you check auto configure connected anchor, you cannot change the position of the connected anchor anymore. It's sort of locked to the position of the anchor. You can't change the position of the anchor. Now, you must be wondering, what is the point of changing the anchor and the connected anchor position? Basically, depending on where you have these anchors placed, you're going to get a different type of behavior from your joint. I'll demonstrate this a little bit later, not right now. For now, bring joint part O1 closer to joint part O2 and change the position of the anchor so that it is now in between these two game objects in this empty space, just like this. It doesn't have to be perfect. Alright, next we're going to talk about frequency. Now, if you remember earlier, I told you that the FixedJoint2D is a spring type joint. So frequency here is basically the frequency at which the spring oscillates while trying to maintain a distance between these two game objects. The frequency is measured in hertz, and to demonstrate how frequency works, I'm going to make some changes to our scene. Select the block game object and bring it a little bit to the side, and make a duplicate of the block game object and bring that duplicate on the other side. Now select joint part O1 and change the frequency to, let's say, 2. And now let's play the game. As you can see, the spring is quite soft, but to a certain extent it is still able to maintain the offset between these two game objects. Now let's change it to something lower than 2, let's say 0.8. As you can see, the spring is now too soft to be able to maintain the offset between these two game objects. Now change the frequency back to 0. As you can see, the spring is really stiff. Alright, now first of all, your frequency range is between 0 and 1 million. However, a frequency of 0 means that the spring is completely stiff. But if you set the frequency to anything other than 0, then the higher the frequency, the stiffer the spring will be, and the lower the frequency, the softer the spring will be. I hope that's clear. Next, we're going to take a look at damping ratio. Damping ratio defines the degree to which you want to suppress spring oscillation. This value can be between 0 and 1, and the higher the value, the lesser the movement. Now let me demonstrate what this means. I'm going to set the frequency to 1.8, run the game. Now you'll notice the spring oscillates quite a bit before finally coming to rest. This is because the damping ratio is set to 0, so there's no damping applied to it. I'm going to set the damping ratio to 1 because that's the max value. It can be anything in between 0 and 1. I'm going to set it to 1 so you can see what full damping looks like. As you can see, the object came to a rest really quick. This is because the damping ratio is set to 1. So this is damping ratio. Next, we're going to talk about enable collision. Now, to demonstrate this, I'm going to increase the size of both of our game objects, just make them taller. And I'm going to set the frequency to something really low, let's say 0.3. And now, before I run the game, I want to point something out. Both of these game objects have rigid bodies attached to them. Both of these game objects also have colliders attached to them. So there should be a collision taking place between these two game objects. They shouldn't intersect each other. But watch what happens when I play the game. As you can see, both the game objects were able to go through each other. They were able to intersect each other. The reason for this is enable collision is unchecked. Because when these two game objects are joined together using the FixedJoint2D component, you do have the option to enable or disable any collision taking place between them. So currently enable collision is unchecked, and so as you can see, the game objects are able to intersect each other. But if I check enable collision and then play the game, As you can see, now both the game objects are actually colliding with each other. So this is what enable collision does. Next, we need to talk about brake force and brake torque, but before that I need to explain reaction force and reaction torque. When a joint tries to constrain a rigid body 2D, it needs to apply a certain amount of force and torque in order to do so. That is called reaction force and reaction torque. We can actually read the reaction force and reaction torque of our joint. To do that, I'm going to add a script to joint part 01. I'm going to call this FJScript03. Open this up in MonoDevelop. Now this is going to be a really simple script. Type FixedJoint2D FJ2D. This is going to be a reference to our FixedJoint2D component. Next, public vector2 reaction force, because reaction force is a vector 2. Then public float reaction force mag. That's the magnitude of the reaction force. Then public float reaction torque. Then in the start method, type fj2d equals get component FixedJoint2D. Here we are basically adding a reference to the FixedJoint2D component attached to this game object. Then in the update method, type if fj2d not equals null. Then reaction force equals fj2d dot reaction force. Reaction force mag equals fj2d dot reaction force dot magnitude, and reaction torque equals fj2d dot reaction torque. Hit save, go back to Unity, and just like we brought our FixedJoint2D component up here, do the same thing with the FJScript03. And before running the game, let's just return both our joint part game objects back to their original size. Also, uncheck enable collision and change the frequency to something like 3, because we want this joint to be able to hold up over here. And now hit play. As you can see, we are able to see reaction force magnitude, and also reaction torque. Now this is where brake force and brake torque come in. Let's say I specify a brake force of 10, then at any point if the reaction force magnitude of this joint crosses 10, the joint will break. Let's see if that happens. As you can see, the joint broke. When I say the joint broke, that basically means that the joint has been removed from this game object, and both these game objects are not connected anymore. And if the brake force is set to infinity, then that basically means that the joint is unbreakable. It's not going to break. So it's a very flexible joint then. And the same logic applies to brake torque. If the reaction torque goes more than the brake torque that you have specified, for example, let's say 5, then the joint will break. And just like brake force, even brake torque can be set to infinity, in which case the joint is not going to break. Now, I want to make one thing clear. The aim of the FixedJoint2D component is not to make two objects look like they are in a straight line or something like that. The aim of the FixedJoint2D is to maintain a relative linear and angular offset between two game objects. What this means is that, let's say I rotate joint part 01 like this and change the position. So now it's not exactly a straight line. And now if I play the game, as you can see, the joint is not trying to make both of them into a straight line. The joint is trying to maintain the original orientation or the original offset of both of these game objects. Because notice how these two game objects are forming a certain shape. This shape is what the joint is trying to maintain. More specifically, the offset between these two game objects is what the joint is trying to maintain. These two game objects have a certain linear and angular offset from each other. The joint is basically trying to maintain that linear and angular offset. Alright, so as I told you earlier, I'm going to show you how changing the anchor point position can give you different types of behaviors. So let's bring both these game objects back into a straight line. Now I'm gonna change the frequency back to something that makes the spring really soft. So let's say 0.3. Now when I run the game, as you can see, the joint is not able to maintain the offset really well. Now I'm gonna leave the frequency exactly as it is, and I'm gonna change the anchor and connected anchor position. Well, I'm gonna change the anchor position, and connected anchor is just gonna follow because auto configure connected anchor is checked. I'm just gonna change the anchor position on the y-axis and bring the anchor point up here. And now when I run the game, watch the behavior. As you can see, the behavior is completely different now. Now it's acting as if the spring is stiff. This is just one example of the different types of behaviors that you can get by changing the anchor position. Let's take another example. I'm going to change the anchor position on the y-axis back to 0, and now I'm going to set connected rigid body to none. So at this point, the connected anchor is basically a position in world space. Joint part O2 is not connected to joint part O1. And now watch what happens when I run the game. You have a sort of hinge joint kind of behavior. Now I'm gonna change the anchor position on the x-axis and I'm gonna bring it somewhere a little far. And I'm also gonna move this game object a little up here. Now when I play the game, you can see a much bigger rotation happening as compared to before. This is just to show you that the anchor points play a big role in how the joint is going to behave. When you change the anchor point positions, you can get different types of behaviors from the FixedJoint2D. Now the FixedJoint2D can be used in many different situations, but two situations I would definitely recommend it for are situations where you want to have breakable objects, for example a box, a chair, a table, a bridge, etc. and situations where you want to put multiple pieces together and have them behave as if they are one object. So yeah, I guess that's it. Alright, I hope this video was helpful. If you'd like to check out more videos, head over to my channel, and there should be 2 videos up on the screen right now as well. If you'd like to check out my music channel, it's called Demkeys Music. The link should be up on the screen right now. If you'd like to help me out with a donation, my PayPal email address is mentioned up on the screen and in the description down below. Don't forget to like, share and subscribe. Leave your comments below, and I'll see you guys next time.